Welcome to the discussion and thank you for always joining us. This is K.c.s.e 2007 paper 2 number 22 linear programming, and the question we have reads: a company is considering installing two types of machines, A and B. The information about each type of machine is given in the table below. We have the type of machine, that is A and B, the number of operators, the floor space that is covered, and the daily profit generated from the assignment. The company decided to install X machines of type A and Y machines of type B. Part A of the question, write down the inequalities that express the following condition. The first condition is where we have the number of operators available is 40. Remember, machines are directly proportional to the number of operators, and in this case we have two machines of type A. We have two operators in machine A, and the number of machines installed are X, and therefore the total operator machine will be twice X, plus we have 5 operators in machine B, and the total here will be 5 times Y, and the total number of operators available are 40. That means the total of this will be less or equal to 40. This becomes the first inequality. 2, the floor space available is 80 meters square, and therefore we are going to have 5. That is the floor space. We multiply by the number of operators. Then we are going to have 8y, and this one is going to be less or equal to 80, because that is the total floor area available. This becomes 2. We are also told that the company is to install not less than 3 type A machines. Type A machines are X, and therefore we are going to be having X being greater or equal to 3 as the third inequality. And the last one is that the number of type B machines must be more than 1/3, meaning Y will be greater than 1/3 X, and this becomes the fourth inequality. From there, on the grid provided, draw the inequalities in part A above and shade the unwanted region. We are going to start by having a table for the first one, having X and Y. We are going to assume that the value of X is 0 for the first one, then Y is going to be 8, and if we assume Y is 0, then we are going to have X as 20. For the second one, which is 5X plus 8Y is less or equal to 40, we again make a table having X and Y. When the value of X is 0, for example, then Y is going to be 10, and if we assume the value of Y is 0, then X is going to be 16. For the fourth one, which is Y is equals to 1/3 X, we can also make a table having X and Y, and this one is going to be, if we assume that the value of X is, for example, 0, then the value of Y is going to be 0. If you assume the value of X is 3, the value of Y will be 1. And if we assume that the value of X is 6, then we are going to have the value of y as 2. If we assume that the value of x is 9, for example, then this one will be 3. Those points are enough for us to draw our table. From here now, we are going to go straight and start drawing the lines and shading. For the first one, when x is 0, y is 8. When x is 0 at this point here, y is 8 here. And when x is 20, y is 0. At 20, y is 0 at this point. So we are going to draw a line joining the 2 points. Then we shade the required part. That is what we have. Remember, according to the inequality, what we need is below the line, and therefore we are going to shade the upper part this way very quickly. So this is 2x plus 5y is equals to 40. We move to the second one. When x is 0, y is 10. When x is 0, y is 10 at this point here. And when x is 16, y is 0 at this point here. Again, we are going to draw a line joining the 2 points like this. Once we have drawn that, again what we need is below the line. So we are going to shade above. We are also going to label this line as 5x plus 8y is equals to 40. Then we move to the third one, where we have x is greater or equal to 3. So again, we are going to go to where we have 3 and draw this line. 3 is between, it's midway between 2 and 4. So we are going to draw a straight line this way and a shade. This is where we have x is greater or equal to 3. So we are going to shade the region behind. And lastly, we are going to move to the last one, where y is greater than a third. So we are going again to draw this. When x is 0, y is 0. When x is 3, y is going to be 1 at this point here. When it is 2, when it is 6, it is 2 here. When it is 9, it is 3 at this point here. So from here, we are going again to draw a straight line joining the points that we have drawn. Here we are going to use a broken line because the region we have is not included. Having done that, we again look at what we are going to shade, but this is y is equals to a third x. What we need is above the line, and therefore we are going to shade the region below. And by so doing, now we are going to have our required region at this point here. Once we have done that, we have done the shading and everything. That is part B and part A done. Then C, draw a search line and use it to determine the number of machines of each type that should be installed to maximize the daily profit. So what we are going to do, we are going to use the objective function, and we are told that the daily profit for type A is 1500. So we are going to have 1500 times x plus, we have 2500 times y. We can decide to equate this to 15,000 and then use it as the search line. So 15,000 is our approximate value. Divide by 100 all through, we are going to have 15x plus 25y being equal to 150. So we can make a table having x and y, and when the value of x is, for example, 0, the value of y is going to be 6. And if we assume that the value of y is going to be 0, then x is going to be 10. We are going to use these 2 points to draw our search line. So when x is 0, y is 6 at this point here. And when x is 10, y is 0 at this point. So we are going to draw this search line here and then use it to so this is our search line. This is our search line. Then from the search line, we are going to determine the number. We are going to determine the number of machines of each type. In this case, I'm going to pick all the points along the search line. So from here, we can move the tri-square from the search line so that we can get the maximum points. But in this case, since we cannot be able to use the search line to use the tri-square here, we will be forced to use the corner points. We will be forced to use the corner points at this point again. So all these corners will give us all the points that we need, but the point that is going to give us the highest number of machines required to maximize the profit would be at this point here, where we are going to have x being around 4.2, and that one is approximately 4, and the value of y down here would be, so this is x is 9 down here, and the y is around 4.2, which is 4. That means type A would be having 9 and the type B would be having 4, and that is the solution to this particular question. Thank you for watching and welcome to our discussion. And in case you're watching this channel for the first time, please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. You can use this question, move with the tri-square for you to locate the values that I have already indicated. Thank you and welcome.